Have you ever reached for a doorknob, and right before you touched it, zap, you get a tiny, surprising shock? Or maybe you've taken off a fuzzy sweater in the dark and heard a crackling sound, or even seen tiny sparks. What is going on there? Let's set up a common situation. It's a dry winter day, and you're inside, wearing socks. You shuffle your feet across a carpeted floor, just walking from one room to another. You haven't done anything unusual. You're just walking. But in the invisible world all around you, something incredible is happening. You then go to open a door. Your hand reaches out, getting closer and closer to the metal doorknob. You feel a little tingle in your fingertip, and then that familiar little zap happens. It doesn't really hurt, but it always makes you jump. To understand that zap, we need to zoom in. Way in. We need to look at the world on a scale so small you can't see it. Everything around you, from the carpet on the floor to the air you breathe to you yourself, is made of tiny things called atoms. Think of atoms as incredibly small building blocks. Billions and billions of them fit together to make up everything that exists. Even though they are impossibly small, atoms are themselves made of even smaller parts. In the center of every atom, there's a core called the nucleus. This nucleus contains particles called protons and neutrons. But orbiting around that center, like tiny planets around a sun, are other particles called electrons. Protons have what we call a positive charge, and electrons have a negative charge. Usually, an atom has the same number of protons and electrons. This makes the atom balanced or neutral. It's happy and stable, with no overall charge. Now here is the secret to our mystery. Those little electrons on the outside are not always stuck in place. Some electrons are held very loosely. With just a little bit of encouragement, they can jump from one atom to another. They are the restless travelers of the atomic world, and their movement is the key to understanding static electricity. So let's go back to you shuffling your feet on the carpet. When your socks rub against the carpet fibers, you are creating friction. This rubbing action is the encouragement those electrons need. It gives them enough energy to leap from the atoms in the carpet to the atoms in your socks. The carpet is literally giving away some of its electrons to you. They travel up from your socks and spread out all over your body. Now, your body is no longer balanced. You have collected a ton of extra electrons, which all have a negative charge. Your body now has an overall negative charge. You have become a walking, talking storage unit for static electricity. The carpet, having lost all those electrons, is now positively charged. But you are the one who is walking away with all that extra negative energy. You walk over to the door, still carrying this invisible cloud of extra electrons all over your skin. You don't feel anything, because the charge is just sitting there. That's why it's called static electricity. Static means not moving. But this imbalance is not a natural state of things. Nature loves balance. It wants to even things out. All those extra electrons crowded onto your body are looking for a way to escape. They want to flow to a place that has fewer electrons to restore that balance. They are just waiting for an opportunity, a pathway to get away. And then you provide one. You reach your hand toward the metal doorknob. Metal is a great conductor, which means electrons can move through it very easily. It's like a perfect escape route. As your finger gets very close to the doorknob, the pull from the metal becomes too strong for the electrons to resist. They don't even need you to touch it. The electrons build up on the tip of your finger, and then, all at once, they make a giant leap. They jump through the tiny air gap between your finger and the doorknob. That massive, sudden rush of electrons is the spark you see and the shock you feel. It's a miniature lightning bolt created by your own body, as nature instantly balances the charge you built up. So that little zap isn't just some weird quirk. It's a direct demonstration of one of the most fundamental rules of physics. It shows that the world is built on tiny, charged particles and that nature is always trying to keep things in balance. That flow of electrons, whether it's a tiny zap from a doorknob or the electricity powering your home, is all the same basic principle. It's the movement of countless invisible electrons that powers our entire modern world. So is there anything you can do to avoid getting zapped? Yes, there is. The secret is giving those electrons an easier way to leave your body. Static electricity builds up more in dry air. Using a humidifier can help, as the moisture in the air allows the charge to leak away from you slowly. Or you can try a simple trick. Before you touch a metal object, touch a wooden wall or door first. Wood is a poor conductor, so it lets the charge drain away gently, without the sudden zap.